Imagine this. You wake up in a massive city, towering buildings everywhere, bridges spanning rivers, roads cutting through mountains. But here's the problem. You don't remember building any of it. You look around and find some tools, a shovel, a hammer, a pickaxe, and somehow you're supposed to believe that you built all of this with those. Absurd, right? But that's exactly the situation humanity found itself in during the 19th century with railroads. In just 20 years, the planet was covered with a network of rails longer than the distance to the moon. And supposedly, people did this with wheelbarrows and shovels. The numbers don't add up. The technology doesn't match the result, and the logistics a complete nightmare. Today, we're going to expose one of the most suppressed paradoxes in history, a paradox that destroys the entire official narrative of the Industrial Revolution. What you're about to learn will make you question every single page in your history textbook, because this isn't a story of construction. This is a story of discovery. Get your calculator ready. You're going to need it. Let's start with the math, because the math alone destroys everything they taught you. 1830, the world's first commercial railroad opens, Manchester to Liverpool, just 30 miles. 1840, only 10 years later, the planet has 5,000 miles of rail. 1850, just 10 years after that, 25,000 miles. In 20 years, humanity created a transportation network longer than the distance from Earth to the moon and back. Let that sink in. 20 years. No excavators, no trucks, no electricity, no computers, no radio communication. The United States, 1865 to 1900, 186,000 miles of railroad in 35 years. That's 5,300 miles every year, 14 miles every single day, no weekends, no holidays, for 35 years straight. The Russian Empire, 1865 to 1900, 33,000 miles of railroad through swamps, taiga, and permafrost, in a country where 80% of the population were serfs. Understand the insanity of this scale. All of this was supposedly done by men with shovels, wheelbarrows, and pickaxes. Let's translate those miles into actual physical work that cannot be ignored. For every mile of railroad, you need a perfectly level embankment, 6 to 10 feet high, 16 to 23 feet wide. That means 21,000 cubic yards of earth per mile, soil that needs to be dug, moved, and compacted. For 186,000 miles of American railroads, that's nearly 4 billion cubic yards of earth, moved by hand. That's more than the volume of all the Egyptian pyramids combined, multiplied by 1,000. One Egyptian pyramid, the Great Pyramid of Giza, 3.3 million cubic yards, built over 20 years with tens of thousands of workers. But here, 4 billion cubic yards in 35 years, while simultaneously building cities, factories, bridges, and train stations. Have you ever tried digging a trench with a shovel, even just 30 feet? Now multiply your effort by 300 million, and imagine doing all of that in a few decades. The mathematics is screaming at us. This is physically impossible with the tools that were available.
Now let's be honest about the question nobody wants to ask. What did they actually build this with? The 1830s through 1850s, what tools were available to the average construction worker? A shovel, a pickaxe, a wheelbarrow, a horse and cart, a hammer, a saw, and gunpowder for blasting. That's it. That's the entire arsenal. The steam-powered excavator was invented in 1836, and it was so primitive and expensive that it was used on maybe a handful of major projects. Dynamite, which could have simplified tunnel digging and rock clearing, wasn't invented until 1867, which means most of the world's rail network was built without it. The gasoline engine appeared in 1885. Electricity on construction sites didn't begin until the early 20th century. So the toolkit of 19th century builders was practically identical to what the Romans had 2,000 years earlier. But the Romans, in 500 years of dominance, never built anything even remotely comparable to the railroad network. Yet in the 19th century, it was done in 20 years, with the same tools. Explain that logic. Let's talk about tunnels, because this is where the absurdity reaches its peak. The Semmering Tunnel in Austria, length 4,600 feet through alpine rock. Construction 1848 to 1854. 6 years of pounding through a mountain with pickaxes, hammers, and black powder. Result, a perfectly straight tunnel with accuracy down to the fraction of an inch. And here's the truly incredible part. The tunnel was dug simultaneously from both sides. When the workers met in the center of the mountain, the deviation was just 0.8 inches, less than an inch over nearly a mile through solid rock. No lasers, no GPS, no electronic measuring instruments. Modern engineers with computer modeling and laser navigation consider this level of precision an outstanding achievement. The Gotthard Tunnel in Switzerland, 9.3 miles. Construction from 1872 to 1882. 10 years of continuous work. Dynamite was literally invented during construction, which means most of the tunnel was hammered out with regular gunpowder and by hand. For comparison, the new Gotthard Base Tunnel, 35 miles, was built from 1999 to 2016. 17 years with giant tunnel boring machines. 35 miles in 17 years with robots versus 9.3 miles in 10 years with pickaxes. The ratio doesn't compute. Now it's time to talk about materials, because this is where the logistics nightmare truly begins. For 1 mile of railroad, you need 210 tons of steel for rails, 2,500 wooden ties weighing about 55 tons, 9 tons of fasteners, and 3,500 tons of crushed stone for ballast. Total per mile, 270 tons of metal, 55 tons of wood, and 3,500 tons of stone. The world's steel production in 1870 was just 550,000 tons per year. For American rails alone, you'd need 45 million tons. That means the entire world's metallurgy would have had to work for 90 years exclusively on American railroads, producing nothing else. But during this same time, bridges were being built, ships, factories, weapons, tools, household items. Where did the metal come from for all of that? Iron and steel don't grow on trees. They have to be smelted in blast furnaces, which require enormous volumes of coal or charcoal. Every ton of steel requires 1.5 tons of coke. For 45 million tons of steel, you need 67 million tons of coke. Where did they get such volumes of fuel? Where were these gigantic metallurgical complexes capable of producing millions of tons per year?
Let's say you somehow have all this metal, wood, and stone. Now explain how you transport it to the construction site. On what roads are you going to haul 210 tons of materials for every mile of track, through virgin forests, prairies, or mountains?
The dirt roads of the 19th century turned to mud after every rain. Even an ordinary cart with a load of a few hundred pounds would get stuck hopelessly. Try moving loads weighing tens of tons on such roads. The wheels would sink up to the axles in mud. The axles would break. The horses would collapse. Historians say materials were transported by water, by rivers and seas to the nearest dock. Fine, but then what? From the dock to the center of the continent, to the heart of Siberia, to the prairies of the Wild West, to the jungles of India. And most importantly, how did they deliver materials for building the very first railroads when railroads didn't exist yet at all? This is a perfect logical paradox with no solution. To build a railroad, you need a railroad to deliver the materials. But the railroad doesn't exist yet because you're still building it. So materials have to be transported over trackless wilderness, which is physically impossible in such volumes. A closed loop with no exit within the official version of history. For construction of the trans-Siberian Railway, 90,000 workers were needed simultaneously at peak operations. That's an entire city. Siberia in 1890 was practically a desert, with a population density of less than 1 person per square mile. The nearest villages were hundreds of miles apart. So where did 90,000 workers come from? These people had to be brought from somewhere far away, housed in barracks in the middle of the taiga, fed 3 times a day, that's 270,000 meals every single day, clothed for work in Siberian temperatures of -40 degrees, provided with medical care, paid wages. All of this in conditions of complete absence of any infrastructure. Official history claims they hired convicts and peasants from all over Russia. Excuse me, but the total number of convicts in all of Siberia was about 30,000 people across all the labor camps, and there were almost no peasants in Siberia. Where are the archaeological traces of these huge worker settlements? Where are the mass graves of thousands of people who inevitably would have died in such conditions? There are no settlements, no graves, no documentary evidence of supplying such an army of workers. The only logical explanation, there were far fewer workers because they weren't building tracks from scratch. They were clearing and restoring already existing infrastructure. Now let's pay attention to the train stations because something completely inexplicable is happening with them. Moscow Railway Station in St. Petersburg, built in 1851. Area 43,000 square feet. Tower height 164 feet. Finished with granite and marble. Inside, gold gilding, stucco, frescoes. The population of Petersburg in 1851 was 485,000 people, of which maybe 5 to 10% of the elite actually traveled by train. That's a maximum of 25,000 to 50,000 potential passengers. With 4 or 5 trains per day, that's 200 to 300 actual passengers daily. For 200 people per day, they build a palace of 43,000 square feet with marble columns. St. Pancras in London, 1868. Facade length, 656 feet. Neo-Gothic style with dozens of turrets. Inside, a built-in luxury hotel with 300 rooms. Grand Central in New York, 1913. Area, 47 acres. Marble walls, ceiling painted with a star map. Designed to hold 750,000 people simultaneously. In 1913, New York had 5 million people, and they built a station with capacity for 15% of the entire city's population at once. These aren't stations, these are temples, cathedrals, sanctuaries, built obviously not for the utilitarian purpose of transporting a few hundred passengers per day.
Now, let's talk about something that should have raised suspicion in any rational person. Standards. The width of the railroad gauge in most countries of the world is 4 feet 8 5/10 inches. The
the so-called European or standard gauge. The official version claims this size appeared by accident in England because the first rails were made the same width as mining carts, which were based on Roman chariots, which the Romans sized based on the width between horse tracks. Complete nonsense. But that's not even the point. The point is that this standard spread across the entire world in 20 to 30 years. How did this happen? Without global coordination, without international organizations, without the internet, without even decent telegraph communication. Every country built its railroads independently, using its own engineers and workers, but all of them, as one, chose the exact same standard. This only works in one scenario. If the standard wasn't chosen, it already existed. It was embedded in the infrastructure itself. If the tracks, embankments, and trenches were already laid with this measurement, and 19th century builders simply had to follow the traces they found. Pay attention to how deep the old railroad stations and platforms are relative to the current street level. Go to any station built in the 19th century. The platforms are 3 to 6 feet below the current ground level. Archaeologists explain this as cultural layer. Over 150 years, the city rose about 3 feet due to accumulation of soil, garbage, and building materials. Fine, but then why are the rails also at this lowered level? Did they lay them down and then the entire city around them rose? Or is it more logical to assume the opposite? The city was originally at normal level. Then a catastrophe occurred. Everything was buried under a layer of soil. And in the 19th century, excavations began. They dug up buildings, they dug up roads, they dug up rail tracks. That's why the first floors of many old buildings are below the modern ground level. That's why stations seem sunken. That's why old stations look semi-underground. They weren't built at depth. They were excavated from under a layer of earth. Take any railroad map and pay attention to the routes. Over huge sections, perfectly straight lines for hundreds of miles, ignoring the natural terrain. There's a hill in the way? Cut through it or blast a tunnel. A valley? Fill it with a giant embankment. A river? Build a bridge. All of this to avoid deviating from a straight line. For a 19th century builder with a shovel, every yard of elevation or descent means cubic yards of earth that must be dug by hand. It's hellish labor. Logic would dictate laying tracks through lowlands, following river valleys, going around hills and mountains. Labor savings by factors of 10. Time reduction by factors of several. But no. The railroads on key sections stubbornly go in straight lines, as if whoever designed them possessed technologies for which terrain didn't matter. Or these tracks already existed. They were laid by a civilization with completely different capabilities, and 19th century builders simply followed the trenches and embankments they found. The trans-Siberian Railway over huge stretches runs absolutely straight, despite hills, swamps, and forests, as if someone drew a ruler across a map and said, "The road will be here," paying no attention to obstacles. There exist maps from the 15th and 16th centuries showing trade routes and postal roads as perfectly straight lines between cities. Official history explains this as artistic generalization. Cartographers supposedly just schematically showed the direction of movement. Then why do the railroads built in the 19th century, accurate to the mile, follow the routes of these old schematic lines? The trans-Siberian Railway almost completely follows the route of the Siberian Tract, which existed long before the official construction of the railroad. The first railroads in Europe follow the same routes as ancient Roman roads, but with one difference. Roman roads were dirt, but beneath them they find traces of some kind of solid foundations. The Moscow-Petersburg Railroad runs in an almost perfectly straight line that was marked on maps as early as the 15th century as the main trade route. Coincidence? Or did those roads really exist? Were they actual transportation arteries with hard surfaces, perhaps even with rails, simply buried later? The maps preserved the memory of them. The routes remained in folk memory. And when excavations began in the 19th century, people followed these old paths. They weren't inventing routes from scratch. They were restoring what had already been laid by someone else in the distant past. And since we're talking about found technologies, let's discuss the locomotives themselves, because their evolution looks extremely suspicious. The first working steam locomotive was created by Richard Trevithick in 1804. The first commercial locomotive was launched by George Stephenson in 1825. By 1850, just 25 years later, locomotives were already reaching speeds of 62 miles per hour and operating with astonishing reliability. For comparison, from the creation of the first automobile by Carl Benz in 1885 to the appearance of truly reliable and fast cars, more than 20 years passed, and that was with already developed metallurgy, chemical industry, and engineering education. But locomotives evolved from primitive prototype to perfect machines in 25 years. In an era when metal was forged by hand with hammers, when electric lighting didn't exist, when blueprints were drawn with pens on paper. How did they calculate the most complex thermodynamics of steam boilers? How did they achieve hermetic sealing at 220 pounds of pressure? How did they machine pistons with accuracy to thousandths of an inch? They didn't have computer numerical control machines, no computer modeling, not even mechanical calculators for complex calculations, and yet locomotives from the 1850s worked flawlessly for decades, which is only possible with perfect fitting of all parts. It looks as if they didn't invent locomotives from scratch. They were copying finished samples found somewhere in a preserved state. And here's the final nail in the coffin of the official version of history: the incredible synchronicity of railroad development across the entire planet. In the period from 1830 to 1850, railroads simultaneously appear in dozens of countries on different continents: Italy, Austria-Hungary, Spain, India. Everyone suddenly starts building rail tracks using practically identical technologies and standards. How is this possible without global coordination in a world where there were no telephones, no radio, and the telegraph had only just appeared and was available to a handful of people? An engineer in St. Petersburg and an engineer in Boston, independently of each other, arrive at identical technical solutions, use the same gauge width, build the same types of bridges and stations. This is a statistically impossible coincidence that cannot be explained by simple exchange of experience through occasional publications in scientific journals. The only reasonable explanation: they didn't need to invent and coordinate. The task of the 19th century was not creation from scratch, but restoration of what was found, excavation and launch of already existing infrastructure. That's why everything appeared so quickly and so synchronously. They weren't building, they were digging it up.
Let's talk about bridges that were supposedly built in the 19th century with primitive tools. The Landwasser Viaduct in Switzerland, built from 1901 to 1903. Height 213 feet. Length 446 feet. Material limestone with no reinforcement whatsoever.
This is stone lacework at the height of a 20-story building that has stood for over 120 years, and heavy trains still run across it today. How did they lift stone blocks weighing 4,400 to 6,600 pounds to a height of 213 feet without cranes, without concrete, without steel reinforcement? Historians talk about winches and pulley systems, but try to imagine you're standing on the ground. You need to lift a 3-ton stone to the height of 20 floors using only ropes and wooden structures. Every such lift is hours of work by dozens of men with risk to their lives, and there are thousands of such blocks in the bridge. Moreover, the stones are cut with millimeter precision. They fit together perfectly without mortar. In some sections, modern stonemasons with diamond saws and laser levels cannot achieve such accuracy. But in the 19th century, they did it with hammers and chisels. And most amazing of all, this bridge was calculated to bear loads without computer modeling, without material testing, without mathematical stress analysis, but it stands and works flawlessly. Either the engineers of that time were geniuses at the level of aliens, or they were restoring something that already existed, simply replacing destroyed elements. Let's return to the people who supposedly built all of this. Another point that completely destroys the official version. For construction of such volumes of railroads, millions of hands were required, not just laborers, but skilled craftsmen, stonemasons, carpenters, blasters, surveyors, engineers. Where did the millions of specialists come from in a world where most of the population were illiterate peasants? In Russia, by 1860, 80% of the population were serfs who physically could not leave their villages to work on construction sites. In the United States, the Civil War raged from 1861 to 1865. Millions of men were mobilized into armies, but railroad construction didn't stop for a single day. Moreover, it was precisely during the war period that thousands of miles of tracks were laid. Who built them if all able-bodied men were fighting? Where are the traces of the presence of those 90,000 workers on the trans-Siberian? Barracks, dining halls, hospitals, cemeteries. Archaeologists don't find mass burials of workers from that period, don't find remains of worker settlements along the railway lines. It creates the impression that these huge armies of workers simply didn't exist, that the actual builders were many times fewer, because the main volume of work had already been done by someone before them. Let's return once more to the question of tools, but now let's look at it from a different angle, from the angle of work quality. Rails from the 19th century were cast and rolled with such precision that the joints between them had gaps of no more than 1/10 of an inch over the length of 40 feet. Modern rail production requires the most complex rolling mills, precise temperature treatment, multi-stage quality control using X-rays and ultrasound. In the 19th century, none of this existed, but the rails turned out so high quality that the technology of their production raises questions to this day. Ties were laid with precision of spacing between centers of plus or minus 0.2 inches per mile of track. How did they control this without laser rangefinders? Embankments were compacted to such density that they didn't settle under the weight of trains for decades. What rollers did they use for this, if steamrollers only appeared at the end of the 19th century? Ballast under the ties was laid in layers of strictly defined thickness while maintaining drainage angles. How did they calculate all these parameters without engineering handbooks and standards? Tunnels were broken through with ventilation shafts positioned with mathematical precision to ensure airflow. How did they know aerodynamics? All of this looks as if the builders were working from ready-made blueprints and technological maps that they inherited from a previous, much more developed civilization. Now, let's talk about the energy required to produce all these materials. Smelting 45 million tons of steel requires a monstrous amount of energy. Every ton of steel requires burning 1.5 tons of coke, or 3 tons of coal. That means 67 million tons of coke just for American railroads, not counting steel production for everything else. Where did they get such quantities of fuel in an era when the coal industry was only just emerging, when mines were primitive and dangerous? Coal production in England, the world leader in this indicator, in 1850 was about 55 million tons per year. But this coal was used for heating homes, factories, locomotives, steamships, and countless other needs. Metallurgy could take at most 20% of total production. That's 11 million tons of coal per year to produce approximately 6 to 7 million tons of steel. At that rate, for 45 million tons of rails alone, you'd need 6 to 7 years of continuous work by all the world's metallurgy. But construction went on for 35 years, parallel to the production of millions of tons of steel for other purposes. The energy balance doesn't add up. And the only explanation, most of the rails and metal structures weren't produced anew. They were found, remelted, or restored from what remained from the previous civilization. Otherwise, the calculations simply don't work. Let's put everything together and see what we get. In the period from 1830 to 1860, humanity supposedly laid 25,000 miles of railroads, built hundreds of giant stations, cut dozens of tunnels through mountains, erected thousands of bridges and viaducts. For this, it was supposedly necessary to smelt tens of millions of tons of metal, move 4 billion cubic yards of earth, cut down millions of trees, extract and fire hundreds of millions of tons of crushed stone for ballast. And all of this with shovels, pickaxes, hammers, wheelbarrows, and gunpowder, without excavators, without dynamite until a certain point, without gasoline engines, without electricity on construction sites, without global coordination. Engineers from different countries created a unified system with a standard gauge width of 4 feet 8 5/8 inches, with identical technical solutions, with station architecture of astonishing similarity. Millions of workers appeared from nowhere, worked in impossible conditions, and disappeared, leaving no archaeological traces. Materials in unthinkable volumes were delivered over non-existent roads. Energy for production was taken from sources that weren't enough even for current needs. The physics doesn't add up. The logistics doesn't add up. The demographics doesn't add up. The energy doesn't add up. Absolutely nothing adds up in the official history of railroads. Do you still believe that people with shovels built this in 20 years? Or is it more logical to assume that the 19th century didn't build railroads? It excavated and restored a global transportation system left behind by a previous civilization. The palace-like stations are former temples and public buildings adapted to new needs. The tunnels, with impossible precision, were cut using technologies we don't know about and merely cleared of debris in the 19th century. The incredible speed of laying tracks is the result not of construction, but of excavations of already existing infrastructure. The unified standards across the world exist because the system was global, built by one developed civilization before the catastrophe. We live on the fragments of something great. We use roads we didn't lay. We ride over bridges we couldn't have built with that level of technology. The real question isn't who built the railroads in 10 years, it's who built them before the cataclysm. What happened to that civilization, and why are the ruling elites hiding this information? Because control over energy resources is control over humanity. If we accept that a previous advanced civilization existed and was destroyed, it raises uncomfortable questions. What destroyed them? Can it happen again? And most importantly, what technologies did they possess that we've been denied? The railroad network might be just one piece of a much larger infrastructure, a global energy grid, a transportation system that used principles we've forgotten or been prevented from rediscovering. The ruling elites of the 19th century didn't build this system. They found it, excavated it, claimed it, and then wrote a history that made them the creators instead of the scavengers. Because if people knew the truth, that we're living in a reset civilization, that advanced societies have risen and fallen before, that the technologies we think are new are actually rediscoveries, the entire power structure would collapse. The narrative of linear progress would shatter, and people might start asking what else has been hidden from them. The paradox of the railroads is just one thread. Pull it, and the entire fabric of official history begins to unravel. The impossibility of the construction timeline, the absence of adequate tools, the phantom workforce, the energy that didn't exist, the materials that couldn't be transported, the synchronous global development without communication, the palace stations built for no one, the laser-straight routes through impossible terrain, the tunnels with precision that defies explanation, the bridges that shouldn't be standing. Every single element screams the same truth. This wasn't built in the 19th century. It was found, excavated, restored, claimed. And the real builders, they existed before the catastrophe, before the reset, before the mud floods and the burial of the first floors, before the rewriting of history. We are not the first advanced civilization on this planet. We are simply the latest, living on the remnants of something far greater, using infrastructure we didn't create, following routes we didn't plan, and believing a story that was written to hide the truth. The railroads weren't built in 20 years. They were uncovered. And the question we should be asking isn't how they did it. It's what happened to the ones who did.